Greetings. Welcome to Self-Assessment Lesson 10, Problem 2. We're going to take a look at problems 2, C, and D here, okay? So you're going to be asked to take a look at these equations algebraically in the instructions, show all your steps, and then use a graphing calculator to check your answers. So I'm going to go ahead and show you how to do the algebraic solution, but it's not really necessarily going to be what we do in our class. So while it is important to know how to do this, that's more of a future thing. We're going to be concerned about finding the solution graphically. That's going to be what you're going to be held responsible for. But nonetheless, like I said, let's do them both. So in part C, they ask us to solve this algebraically. So to do this algebraically, you need to isolate the radical on one side of the equation. So to do that, I'm going to go ahead and subtract 5 from both sides. So we get negative cube root of 5x is equal to 11 minus 5, which gets me 6. Now I don't want any coefficients in front of my cube root either. And so while it may not look like there's a coefficient in front of my cube root, there is. There's a coefficient of -1 hiding right here, okay? And I really don't want that there. I want to have a +1 for the leading coefficient on this. So let's divide out that -1 for both sides, or you can multiply out both sides by -1, however you see fit. And that gives us the cube root of 5x is equal to -6. All right, cool beans. Now I need to get rid of that cube root. So the inverse operation to a cube root is cubing. So I will use the inverse operation of cubing on both sides here. And we get 5x is equal to, and now I don't have -6 cubed off the top of my head, so not a big deal though because we have a calculator. And we'll go parentheses -6 close parentheses cubed, hit an enter, and it's -216. Okay, now go ahead and divide both sides of this equation through by 5, and we get -216 fifths is what we get for our answer. Okay, so let's see what that comes out to be. So -216 divided by 5. Hit an enter, and we get -43.2. So x is equal to -43.2. All right, cool. So just a quick little backup here and do a little more into step right here. If I have the nth root of a is equal to k, then provided that that nth root of a was defined in the first place, in other words, that this expression makes sense, then we know that a will be equal to k raised to the nth power. In other words, if you take the nth root of a and raise that to the n power, that simply comes back out to be equal to a. So that's really the only fundamental tool that you need to have if you're going to solve these algebraically, is to realize that to get that radical off of whatever thing you're looking for, you simply have to raise both sides to the nth power. Okay, let's go take a look at part D here. And in part D, we're going to have a square root. Well, the inverse operation for a square root would be squaring. So we're going to square both sides of this. I'm going to come back and do C and D graphically together in just a moment. But we'll get the algebraic parts out of the way first. So we've got the square root of 5 minus x. Quantity squared is equal to x plus 1 quantity squared. Well, the square and the square root knock each other off. They're inverse operations to each other. So on this side, you get 5 minus x. And on the right-hand side, you get x squared plus 2x plus 1. Okay, now if I subtract 5 from both sides and add x to both sides, I'll get 0 is equal to x squared plus 3x minus 4. In other words, set this equal to 0 because I've got a quadratic. Well, it looks like this thing's going to factor for me, so let's go ahead and do that. And I get x plus 4 times x minus 1. Cool, so that tells me that my two possible candidates are x is equal to -4 or x is equal to 1. As we're going to see here in just a few minutes when we do the calculator part of it, that it's not going to work out so good for the negative 4. That's not going to be a possible solution. Okay, so let's go do the calculator solutions, and then we'll come back and maybe look at algebraically why x equals negative 4 wasn't a solution. So getting back over to the calculator here, I'm going to go to our y equals, and we're going to go back to part C, and we're going to solve that one graphically. And the way we're going to do it is we're just going to go ahead and load it in just how it looks. So in other words, I'm going to put in the left-hand side into y1 and put the right-hand side into y2. So 5, subtract, and then I will go into my math menu, and I'll come down here and get my cube rooter, which is number 4, and I'll put in a 5x, and then into y2, we're going to go ahead and put in 11. Okay, now we know that y2 equal to 11 is a horizontal line passing through 11. And we suspect that the x value that we're going to need for our point of intersection is way off to the left. It's down at negative 43.2. So our x min is going to have to be down like maybe near negative 50. So using those two pieces of information, I'm going to set up my window here. So my x min goes to negative 50. Leave the x max at 10. That's just fine. And then my y max, that's going to have to go up to, let's say, 15, because I got to get to at least to 11. Okay, once I've set those windows, let's go ahead and graph this. There's our cube root function coming in. And there's our horizontal line. And it looks like right around here, we've got a point of intersection. Looks like we come up, and you can see where it passes back up and gets bigger again. So we're going to go in and do a second calc, number 5 for intersect. Let's get our little Frogger guy over as close as we can to the point of intersection here. First curve, second curve, best guess. Hey, lo and behold, look at that, negative 43.2, just like we got algebraically. That's pretty slick. Okay, so to show that over here onto our homework paper, we'll have to make ourselves a reasonable facsimile of what we see on the calculator. So this was negative 50, this was negative 10, this was 15, and this was 10. And we had a graph that looked not quite unlike, but similar to that. And then a graph that looked like that. And the point of intersection right here was at negative 43.2 by 11. But that's the x value. That's the main thing we're looking for. Okay, so that's pretty good. So we've got a pretty good confirmation that we did it correctly algebraically because we got the same answer from a graphical standpoint. All right, let's go do the same song second verse now over here with part D. Let's go take a look at a graphical solution to that problem. So go into our y equals, let's clear out y1, let's clear out y2, and let's type it in just how we see it. So second square root, I'll do this one in y1. So second square root of 5 subtract x, and then down in y2, we'll put in an x plus 1. Okay, we don't know any better, so let's try a zoom in a standard and see if we see what we need to see here. And by Jove, we do. And remarkably enough, we only have one point of intersection, which means there is only one solution, which I'm suspecting is the x equals to 1. Let's go check that. So second calc number 5, first curve, second curve, best guess. And yep, that's what we got. We got just one solution, and it looks like it's at x equals to 1. So again, making a reasonable copy of this onto our homework sheet. Looks like we got a graph that looks something like that, with the point of intersection here is at x equals to 1. Okay, so let's think about algebraically for a minute. Why is it that this doesn't work? Okay. Well, let's go plug it back up into the original equation. In other words, let's take a look at the square root of 5 minus negative 4 and set that equal to negative 4 plus 1. In other words, wherever I find an x, replace it with a negative 4. So under the square root, we get 9. On the right-hand side, we get negative 3. Well, no, wait, that is the positive square root, not the negative square root of 9. And so we end up with square root of 9, which is 3, is equal to negative 3, which we know that's not true. Okay, that is not a true statement. And the problem is right here at this point, you can see what happened is that if we come in here and we square both sides of this, then we made that into a true statement. In other words, we took something that was false and we made it true by squaring both sides. And so that's why whenever you raise something in particular to an even power to eliminate a radical, it's going to be incumbent upon you to make sure that you check your answers. But a better idea, instead of remembering what I just said, is whenever you're working with radicals, always check your answers. Okay, well, hopefully that was helpful, and I'll see you back here for the next one.